The angle between the line segment OA and the line segment OB is denoted by alpha. The angle alpha is usually measured in degrees. A full circle has 360 degrees, and the positive direction is opposite to the direction of the movement of the hands on the clock. A quarter of a circle is a right angle, and it has 90 degrees. Half of the circle is a full angle, and it has 180 degrees. The angles are not measured in degrees only. Just remember your calculator. There are usually 3 ways of measuring angles on the calculator. The first way of measuring angles is in degrees, which are marked with deg on the calculator. When it comes to the second way of measuring an angle, a full circle is divided into 400 parts. This division is called a radian. It's marked with the tag grad on the calculator. The third way of measuring the angle is in radians. This is the most important type of angle measurement, and it's marked with rad on the calculator. What is marked with a radian, and how do we measure angles in radians? Let's look at angle alpha again. As we can see, the current value of the angle is 30 degrees. The angle is actually a sector of the circle, and it looks like a slice of pizza. The sector of the circle is bordered by 2 radiuses and a circular arc. Let's look at the length of the radius and the circular arc. It should be noted that the length of the arc is the length of the curve. This means that we should straighten the curve and then measure its length. Now, let's divide the length of the arc by the radius. Let's see how this quotient changes if we change the radius and the angle. First, we'll change the angle with a constant radius. We can see that if the angle increases, the length of the arc also increases with a constant radius. Of course, the ratio of the arc and the radius increases. Otherwise, the ratio decreases. When it comes to the angle of 180 degrees, this ratio is 3.14. I hope everyone knows this number from somewhere. Now we change the angle with the constant radius. Of course, the length of the arc and the radius change. Regardless of these changes, the ratio of the arc and the radius remains constant. This great feature can be used to measure angles. Since the angle is constant, the ratio of the arc and the radius is constant. This ratio is actually the radian of the angle. We may notice that both quantities represent length, so that the centimeter is shortened during divisions. Accordingly, the angle in radians is a dimensionless quantity. This property of radians is adored by mathematicians and physicists alike. Because of this property, the form of alpha equals p divided by 2 or alpha equals p divided by 2 radian is equally correct. In other words, we may leave out the radian. The more difficult part of the work is done. What is the connection between a degree and a radian? We may find out if we analyze a full circle. As we know, a full circle has 360 degrees. In this case, the length of the arc is actually the circumference of the circle, that is 2rp. If this is divided by the radius, after shortening the r, we see that 360 degrees equal 2p radians. A semicircle, that is 180 degrees, is the half, or p. This is what I suggested earlier. After all this, we can easily calculate the angles for the quarter, sixth, eighth, and 12th of the circle. For example, for an angle of 120 degrees, it is necessary to add up 90 and 30 degrees. The table shows some important angles in degrees and radians. In the end, we can see how we can convert units in arbitrary angles. The simplest way is if you write one proportion. Alpha in degrees relates to alpha in radians, as 180 relates to p. After the multiplication, where the product of the external members is equal to the product of internal members, we can easily express the angle in the form that suits us. Let's look at one example. In the first case, we need to include 20 degrees, and in the second case, p divided by 9. We can see that 20 degrees correspond to p divided by 9 radians and vice versa. In the end, let's see which formulas we need to remember. Look at other videos from this area.